has some tricks to it today, and I think you're going to kind of like it, all right? We're going to look at a couple of ways to divide polynomials today. Division is the only thing we're going to focus on. So get adding out of your, well, don't kick it completely out of your head, but at least for this section. Adding, subtracting, and multiplying, get that out of your head, all right? So 3.3, titled Dividing Polynomials. How about I volunteer to read this first question for me? You okay, Ellie? Yeah. Take a drink of water. All right. Volunteer to read that for me up there.
How can you use the factors of the cubic polynomial to solve a division problem involving the polynomial?
Okay, so we're going to look at factors of cubic polynomials. Cubic being what degree again, kids? Third power. Okay, so we're going to look at how do you take one polynomial and divide it by another. All right. So we're three things that we need to accomplish in order to answer this question. First one, we're going to use what?
Long division.
To polynomials by what? Okay. Second one, this is going to be pretty important today. We're going to use what's called synthetic division to divide polynomials by what, kids? Binomials of the form what? X minus k. That's an important one. And now, I don't know if we'll get to the very end of this today, and if we don't, that's okay, but we're going to use what's called the remainder theorem to help us evaluate functions. Again, this idea of synthetic division is going to be something that we look at today. Anybody ever heard of synthetic division? A little bit? Anybody know what it is? Okay, this is pretty neat. Now, this is going to get kind of long and winded here today, and that's okay. We need to make sure we understand some things. So polynomial long division just says it's what, kids? One way to divide polynomials. An example of something we're going to look at will be like this today. Divide x to the third plus 2x squared plus 6x minus 7 by maybe x squared plus 2. Those are the types of things we're going to look at. How in the world do you do that? Well, I'll show you here in a little bit, but we're going to treat it just like this up here. 162 divided by 11. Instead of having just numbers up there, you're also going to have some variables to work with. And I think you'll get this, right? Synthetic division, it's going to be a shortcut for dividing polynomials by binomials of the form x minus k. The thing you need to understand about this is when you're dividing, you have to have something in here. The x minus k goes out here. It can't be x squared minus k. It can't be x to the third minus k. It has to be x to what power? Okay, it has to be x to the first power minus k. Give you an example right here. If I had something like, well, x minus 4 out here, what would the k value then be? 4. But if it said x plus 16, then k would be what value? Negative 16. So when we get going on synthetic division, the thing I want you to think about is that k value is kind of the opposite of this sign right here, okay? So if it's a minus k, the k is really what kind of a k? Positive. And if there was a plus sign in here, k would be a negative. And we'll look at some examples. You'll get that straightened out here in a little bit, okay? These are going to be the two newbies right here. These are the two things that are going to be new for you. Now, guys, we're going to take what we've known in the past, prior knowledge, and we're going to say, what are these terms? Well, long division. It's a standard division algorithm suitable for dividing multi-digit numbers that is simple enough to perform by what? Hand. We're going to have to do that today with the polynomials. The example I provided on the board there, kids, we said 162 divided by 11 was what, kids? 14 and 8/11ths, right? Okay, so let's make sure we understand the terms. What number is the divisor in this mess? 11 would have been my divisor. So in the example above, a number by which another number is divided by, 11 would be the divisor. Okay? The quotient, simply put, kids, is the answer. It's the result. So what did we get for a quotient? Or what did we get as an answer when we divided that? 14 and 8/11ths would have been the quotient here. How about the remainder? What remainder did we come up with when we divided that? Okay, so 8 would be the remainder. 8/11ths would be the fraction that's left over, but we would say the remainder was 8. And then the dividend is the number we start with. What number are you going to divide or chop up? Well, what number did we start with? 162 would have been that number. Okay. So, as far as terms go, I mean, there's a lot of prior knowledge we should know. I just wanted to refresh that with you. But again, the two things we're going to look at is polynomial long division and synthetic division. And we're going to use synthetic division to help us divide by binomials of the form x minus k. And I think you're going to be like, whoa, that's pretty sweet. Okay? Anybody need more time getting that stuff down there? All goody? All right, anyone else? Okay. Kids, the good news. Here's the good news. The hard part of the notes is at the beginning, not at the end today. Is that okay? All right. It says using polynomial long division. What are we going to divide here, kids? It says to divide 4x to the fourth plus 5x minus 4 by what? Okay, here's the deal. Anytime you do this stuff right here, two things that I want you to do. First of all, your polynomials need to be in standard form. You want your polynomials in standard form. That's the first thing. Your polynomials have to be in standard form. The second thing then is this. When I say they're in standard form, include all powers. So kids, if I start out with a function that says x to the fifth, I would have to make my way from x to the fifth all the way down to x to the 0. So I've got to have an x to the fourth written. I've got to have an x to the third. You've got to have an x to the second, an x to the first, and then all the way down to x to the 0, which is your constant value. So here's what this is going to look like, kids. And this is how I think you should write this to start. Give yourself some room on this. We're going to divide 4x to the fourth plus 5x minus 4 divided by what, kids?
X squared minus 3x.
What's going underneath the division symbol? 4x to the what?
4.
Okay, we all agree that 4 in this dividend right here is the highest power? Okay, so I'm going to put in here 4x to the fourth first, kids. But I have to make sure I write stuff in standard form, and I also have to make sure I include exponents from 4 all the way down to 0. Do you see an x cubed listed anywhere in here at all? So I have to write plus 0x cubed. Do you see an x squared listed in here at all? Nope. So plus 0x squared under here. See an x up there anywhere? So plus 5x. And then we're down to a constant. Just a number with no x by it. So what number is going in the end? Minus 4. Okay? So my dividend, I've put that in their standard form, and we've put all of those terms in there from 4 all the way down to 0. Okay? Now, how about your divisor? What's the power of the divisor? Squared. So you're going to put your x squared out here. Okay, kids. Is there an x term in here? Well, the answer is yes. And then is there a no x term at all? Well, yeah, it's just minus 2. So do I need to rewrite the second one at all, or is that one okay? It's all okay. All right, here we go. You ready for this? You can lie to me and say yes. Here's how this works. Kids, just like division up here, the 11 into 162, you were seeing, all right, 11 leads into not 1, but it will go into 16 right off the bat. So when you're dealing with division of polynomials using long division, you're kind of doing the same thing. You're looking at saying, okay, well, I need to look at my leading coefficient here and here. Okay, really, how many x squared do you have here, kids? So if it helps you, put a 1 out in front of this. All right, put a 1 out in front of that. Okay, And here's how we're going to start dividing. We're going to take that function x squared minus 3x minus 2 and start by dividing that into x to the fourth. Now again, we're not looking at the whole thing. We're looking at just the beginnings of each. So let me ask you this question right here. Kids, my divisor, 1x squared minus 3x minus 2, the part I've underlined up here, how many times will 1 go into this 4?
4.
So I put a 4 up here. Okay? Then, think about it this way. This is x to what power, kids?
4.
Okay, but we're putting an x to the second into it. How many x's are here again, power-wise? 2, and we're going into what? So if I've got 2 here, how many more would I have to put up here to make this a 4? So how many times will 1x squared go into 4x to the fourth? It'll go in there 4x to the what, kids? All right, so just like over here now, guys, you took the 1 times the 11, put an 11 here, and you did what? Well, you subtracted. So you're going to do the same thing here. You're going to take 4x to the second times 1x squared first. What is 4x to the second times 1x squared, kids? What's the 4 times 1? You're right here, you're going to write 4. What's x squared times the x squared? X to the fourth. And then I also need to take the 4x squared times the negative 3x. What's 4 times the negative 3 going to get you? Negative 12. And then the x squared times the x would be x to the third. But I also need to take 4x squared finally times negative 2. So what's that going to get you? Minus 8x squared. Now let me show you something here quickly. I'm going to size this down a bit. Kids, right here, you've got 4x squared up here. This times this mess was all this. Just like I subtracted 11 over here, we're going to take what I've multiplied, 4x squared, by my divisor to get this. You are going to simply go ahead and subtract everything. So here's how this works. The 4x to the fourth minus 4x to the fourth. What happens there? It's gone. It's just gone. That's good. And then we've got 0x to the third minus what? Negative 12x to the third. Well, when you subtract a negative, that's really what? So this is 12x to the third now. And then how about 0x squared minus the negative 8x squared? Positive 8x squared. Okay, so I've done all the subtraction I can do while it's written up there. So like this over here, what did we bring down then for my second division? We brought 2 down. So what would be the next term I could bring down over here? So you're going to bring down a plus 5x. And you know what? We're going through this process again. So here we go. Help me out. How many times will 1 go into the 12 now here? So I'm going to put a plus 12. Guys, how many x's are in the divisor here that we're leading with? 2, but we need to get into 3. So if I have 2, how many x's would go in here then? That would be 12x, wouldn't it? So x squared goes into 12x cubed, 12x times, that's why I have a plus 12x up there. Okay, are you following?
Yes.
I know I'm chatting a lot, but make sure you're following this, all right? So 12x we think. Here we go again. 12x times x squared. What is that, kids?
12x.
Ooh, boy. What do you think's going to happen again on these first terms right here? They're going to drop out. I've got to take 12x times negative 3x, which would be minus 36x to the second. And then 12x times negative 2 will be a minus 24x. All right, help me, kids. What's going to happen to the 12x cubes? They go bye-bye. 8x squared minus negative 36x squared. Where's that? Careful. Subtracting a negative is addition.
44.
Yep, 44x squared. How about 5x minus negative 24x? 29x. Any terms I can bring down, kids? Okay, now that minus 4 was the last term I brought down, right? Keep that in mind. Guess what you get to do again? All of it again. Here we go. Guys, how many times will 1 go into this 44 down here now? So we're going to go plus 44. How many x's am I going to need if I have x squared here and I want to go into x squared there? I don't need any. Okay? So 44. Here we go. So 44 times this mess. Help me out. 44 times x squared is what? Okay. 44 times negative 3x, I'll tell you, is minus 132x. And then 44 times negative 2 is negative 88. So we'll subtract again. What are the 44x squareds going to do here? They're gone. How about 29x minus 161x? And how about negative 4 minus negative 88? All right, now listen to what I say because this is pretty important right here. Kids, are there any other terms to bring down from the dividend? Not at all. So what this really means is if there's nothing else to bring down, then that means that everything down here, kids, is a remainder. This is what's left over. So over here, our simple division problem numerically, what was our remainder? And we put 8 over the divisor of 11 to call us 14 and 8/11ths, right? We're going to do the same thing here, but your remainder up top is going to be 161x plus what, kids? 84 over the divisor of... Okay, and then this, so this will be plus 161x plus 84. Oh, lordy, I missed. Should be an 84 here. Give me a second. Let me fix that. Plus 84 over x squared minus 3x minus 2. That, my friends, is your answer.
That's too much.
That is that's a long laundry list right there, isn't it? Okay. Now, here's the situation today, kids. Right up here, we were dividing by something that had x to what power? Okay. I've got bad news. If they have something out there other than just an x, if your leading degree or your degree of the divisor is 2 or higher, they're going to have to do it that way. All right? But I want to show you something that's pretty cool because what we're going to start running into, guys, in example 2 is what's known as what, kids? Synthetic division. All right? I'm going to do some work up here, and I'm going to say, you know what? Watch me divide. I'm not going to make you do a division problem here, but here's the situation. First of all, any questions on this? Okay, let's run down to example 2. This says use what, kids? Okay, I'm gonna do this problem on a different sheet. So would you guys tell me what I have to divide? What's going on underneath the divide side? Don't write this part down.
You have to take
Negative?
3x plus, I meant x to the third.
Okay.
Plus 3x squared.
Okay.
Plus x by x minus 2. Divided by.
Right over here?
Yep.
Okay, help me out, kids. I've got a power of 3, a power of 2. This is really a power of 1. Guys, what constant's really out here if there wasn't a constant number out here? Plus 0. So you need to put that. If they don't have like a plus 2 or a minus 4 or a plus 66, if there's no final number out there, you have to put what out there? Okay, don't write this. Watch what I get for an answer. I'm going to divide this out. Now keep in mind, we're dividing really by x to what power here, kids?
Okay.
Okay, well, x really to the first power, okay? Something special happens when we start dividing by x to the first. And I'm going to show you what the answer is going to look like here long division. Don't write this out. But then I'm going to show you how this ties into what we're going to head into. Okay. All right, guys. This is really 1x. This is negative 1x cubed. How many times will 1 go into negative 1? Wouldn't it be negative 1 time? Negative, all right, there's 1x here, and there's 3 here, so negative 1x to the second. All right, I'm just going to fly through this. I'm going to multiply this by this, so this becomes negative 1x cubed plus 2x squared. Let's see, I subtract these. These cancel. You trust me, guys? I mean, it's okay if you don't, but do you trust me to go ahead and just do this without asking questions? Okay. What do I get for an answer? Is that right?
You have to get the x in it.
Oh, yeah, no. Who said that? Haley Nathan! All right. I want to show you something. This is so neat, and I get excited about stuff like this when I see things like this. We're dividing by something that's known as x to the first power. Okay, it's a binomial, x minus 2. Okay, synthetic division only works when you divide by x minus k. Am I dividing by an x minus k form right here, kids?
Yeah.
What value is k here?
Positive 2.
Positive 2. It's going to be 2. It's kind of the opposite of that sign there, okay? Here's what you're going to do. Kids, you're going to put a box up here like so. And you're going to list your k value first every time in this box, like this. You're going to put 2 in here. All right? Now, I'm going to go back to my answer here in a little bit. But kids, I get super duper excited about this. What you're going to do is you're going to write down your coefficients for each term of your dividend. So my dividend was negative x cubed plus 3x squared plus 1x plus what constant on the end did we have to put in there? First term, what's the coefficient?
Negative x cubed.
So what's the coefficient? Negative how many x cubed? Isn't it negative 1x cubed? Put your coefficient down. What's the coefficient for the degree 2 term? 3. You bring a 3 down. The next one, what's the term's coefficient? 1. What's the constant that we get to? What's the constant on the very end? 0. Okay? Here's how this works. What did we say the answer was going to be? Something kind of crazy and long?
Negative x squared
Plus x plus, I don't remember what it was even. All right, here's how synthetic division works. And I'll show you how and how to write your answer in the end. This is what you do. First thing you're going to do is bring that first coefficient down, which is negative 1. Okay? Then you're going to take this value, negative 1, and times it by k. So what would negative 1 times 2 get you? Okay, so then in this column right here, you've got a 3 and a what, kids? You add them. What is 3 plus negative 2? 1. Okay, so again, this number down here, you take 1 times what value? 1 times what? What is 1 times 2? So you put a 2 right here in that next column. And you add that column together. What is 1 plus 2? 3. All right. Well, then I'm going to take 3 times what, kids? 2, which is, and what's 0 plus 6? Okay, now I want to show you something. When you get down here to that last column, put a box like that. That last column is like your remainder. The column before is like your no x's. The column before that is like your x to the first column. And the column before that, where we're at, is like your x to the second column. So what this is really telling me, kids, is this. This is saying this divided by this binomial of the form x minus k is how many x squared, kids? Plus what? Plus 1x. Plus, well, there's no x's, so just plus what here, kids? 3, because x to the 0 is really what value? 1, so it's plus 3. Plus my remainder, which was what, kids? 6. So in fraction form, 6 over the divisor, which would be 6 over what? Let me show you something. You ready for this? How does this answer compare to what I did long-handed here? Same exact thing, right? Now, if you like long-handed division and you want to go through this way, by all means, be my guest, and more power to you, is what I would say. Okay? But if we're ever dividing a polynomial by a binomial of the form x minus k, what kind of division maybe we want to think about using? Synthetic division, okay? Let's try another one here, see if we can't get an answer. In fact, let's go to example 3. Kids, are we dividing by the form x minus k here in example 3?
Yeah.
All right, what's the k value going to be? So put a 1 up here. Help me with my coefficients of the dividend then.
3.
Okay, there's a constant on the end. These go down in order, power of 3, power of 2, power of 1, and a power of 0. All right. What am I bringing down first, kids? Bring the 3 down. Okay, what's going underneath the negative 7? Because that was 3 times 1, right? What's negative 7 plus 3, kids? Okay, so what's going underneath the 6? What's 6 plus negative 4? 2 and the 1. So my last value down here is 10. And 10 is going to be your what, kids? It's going to be your remainder. Okay. Okay. So if this is my remainder, this is my x to the 0 power, my x to the first. So 3 is going to be 3x to the what? So my solution here for this would be simply 3x to the second minus what, kids?
4x.
Minus 4x plus 2 plus what over what?
10 over x.
There you go. It's pretty nifty, isn't it? I don't know about you, but I find that damn cool that it works. I just think that's so cool. I get excited when I see stuff like that. I try to do backflips. No. I don't think you know the phone number for 911. I don't think you call it. Huh?
I said I can teach you how to do that.
Oh boy. This frame? Are you kidding
Yeah.
me? No. This frame is fragile.
All shapes and sizes can do that.
You guys want to try one on your own?
I have a question.
Yeah.
How did you get the -2? Like,
on the example 2
From here?
-1.
Okay, so we brought -1 down, right?
Yeah.
This first number that's down here, you take -1 times the 2, which is -2. Any number that's down here, as soon as you get a number down here, you immediately go multiply and then move that next number over. Okay? Good? You guys want to try one on your own? Here. Do, I'm going to just write it out longhanded for you. I'm going to try and trick you too. See what you get. Be careful. Is there anything that you need to be very careful of right off the bat?
Just missing the cubic.
It's missing the cubic term, so don't forget to put what value as a coefficient in for your cubic term. 0.
Okay.
Careful on your K value as well. Then maybe when you get a solution, check with somebody, see if you agree. All right, kids, what's going to go in here for K?
-4.
Yep. It's kind of the opposite of what's in here. What are my coefficients going to be to start with for my dividend?
4, 0.
Wait, I don't see a 0. Why 0?
Because it's missing the 3.
Missing the x cubed. Okay.
6, -2, 1.
All right. Anybody want to tell me what to do?
4 down to 5 times -4, which is -16 under 0. Add that together, is still -16. Times that by -4 is +64. Add those together is 70. 70 times negative 4 is 280. Add
What
that
kind of
together.
280?
Huh?
What kind of 280?
Negative.
Okay. So this will be negative 282 when I add, right?
Yes.
Holy cow, this is getting out of control. Negative 282 times 4. Oh gosh. Is that, yeah, bud.
How did you get 64 and 280?
Okay, so 64 came from negative 16 down here times negative 4. So 64 is what moves up here. 64 and 6 is 70. 70 times negative 4 is negative 280. When I add these together, negative 282 times negative 4. Help me, 1,000.
1,128.
1,128, I like it. So when I add these up, what's the remainder become here? 1,120. Just give me a show of hands quickly. How many have that remainder there, first of all? Okay. So this polynomial, this fourth degree function, or this quartic polynomial divided by this binomial of the form x minus k, what's that going to look like in polynomial form given these coefficients now?
It is going to
Hang on, Whit. Don't leave us.
4x cubed minus 16x squared plus 70x plus, oh, no, minus 282 plus 1,129 over parentheses x plus 4.
You got it, guys. Kids, that's some pretty upper level stuff right there today. But I tell you what, that concept is crucial. All right, yes?
Why isn't there anything to the fourth power anymore?
Because what we did is we took x into x to the fourth, right? So this is really x to what power? First, it's like saying, hey, I've got this x already. We're going to run it into x to the fourth. So how many x's do I need to team up with this x to the first to take out x to the fourth? How many do you need? Oh, think about it. This is x to the first, right? I want to take out x to the fourth, right? How many more x's are you going to have to throw in with this guy to take that x to the fourth out? There's 4 of them over here, and there's 1 here, right? How many more do you need with this guy to get to this guy?
3.
That's why it comes out x to the third here, kid. Okay?
I don't know very good.
Jeff.
Cough is stressing me out.
Mentally That's not right. I'm mentally strong. Unlike you.
Again, there will not be set instruction tonight after school for the play. We'll finish up the set tomorrow after school. Following students, please report to the office before leaving today. Alex Johnston, Jasmine Hickok, Cole Bruner, B. Cronin, Tessa Pearson, and Alana Eastman.